Okay. All right. So what we're going to be doing today is almost the same exact thing, except when you have a second degree trig function, what do you think your highest exponent is? 2. Second degree. So when you guys were solving something with an x squared in it, what did you have to get it equal to? 0. Good. So that's going to be your first step. Get equal to 0. So if you guys want to get this thing equal to 0, we want to minus the 1 over. And then we get x squared minus x minus 2 equals 0. How did you guys go to solve this? Double. Good. So when you have x squared, it's a little bit tougher than our solving from yesterday. We might have to double with factoring. We might have to use grouping method. We might have to even use a quadratic formula if we can't factor. Right? So we have to look at this. If you guys factor this, factor the 2 that make a 1? Yeah. Good. So x and x, 2 and 1. Which one needs the minus? The 2. Good. Alright, so your last step, what do you have to set equal to? 0. Good. So this becomes x equals 2 and x equals a negative 1. Alright. Now if you guys can solve this, we can solve our first one. It's pretty much the same exact thing. Like how we did yesterday, you made all your trig functions into x's and tried it that way. If it like was tough for you guys, we could do the same exact thing here. So again, you're going to have your interval. Okay, so you want to make sure everything's between 0 and 360. And notice, can we include 360 here? Yeah. And we can include 0. So it's good. Okay. So what we're going to do is think about, as long as we have all the same type of trig function, we can think about the trig function like an x. So if we need to rewrite this, x squared minus x minus 1 equals 1. Right? And now it's the same exact thing that you guys did way up here in the start. I know you guys can all factor. So same exact way. Right? Obviously, hopefully you know that this is going to give you guys the same thing. Is that okay if I just skip to the ending part? Now, just make sure, even though we have x equals 2 and x equals negative 1, we're dealing with x's. What did you guys have originally? Sine. Good. So we want sine theta equals 2, and then sine theta equals negative 1. How did you guys find your theta? What did you use? Second sine. Great. So let's use second function key. So second sine of 2. Good, that's right. Good job. You should get an error here. Okay. Think about your sine graph. If you have a regular sine graph, can it ever hit 2? No, the amplitude would have been 1. So it can't go above that. That's why it's 2 different parts. Right? Yeah, so it won't work. Okay? You could get errors sometimes, that's fine. So this one doesn't work. Now, the sine theta being negative 1, let's see. The second sine, negative 1. We get negative 90. Good. So negative 90, think about negative 90, is that in our interval? No. So what's negative 90 the same as? 270. Thanks, Julia. Just remember going down 90 degrees? This would be the same thing as 270. With back 90. So is 270 in there? Yeah, right. That would work. One thing to be careful of is if you guys have anything with, like, you know, sine or cosine being a negative 1, a 1, or a 0, do a quick little check with your quadrants because your calculator is only going to give you 1. Right? When you guys had your 0, 360, this was the order pair 1, 0. Here we had 0, 1, negative 1, 0, then 0, negative 1. So if you guys wanted the sign to be a negative 1, just give it a double check. Is there anywhere else where the sign is negative 1? It's just this. Here we only have one answer that's going to work.
Is that for like most of the double ones, the second degree ones?
No, they're all kind of different depending on. This is going to happen when you guys get like 1 and 0, where you want to use like this part or negative 1.
So
how was the first one?
Like a lot of double.
Yeah, a lot of factoring. That's going to be the biggest difference. Like this part's the same step at the end, so that's not going to change. Just how hard the factoring is going to be is going different. All right, so let's see. Here's this one. Find the value of x in the interval. Notice your interval here. It's a little weird, right? 0 to only 180. So they don't want anything besides that. All right, they want, okay, cosine squared minus 2 cos x. All right. Now, if this is kind of troubling too with those cosines, make them into x's. So this would become an x squared minus 2x equals 0. Since you guys have an x squared, it's already set equal to 0. But how would we factor this one? GCF. Very nice. Good job. Okay. So we take out an x as a GCF. Right? Fill in your one bubble. So x squared divided by x is x minus, which is going to give us a 2 equals 0. Now when you set these equal to 0, you would have x equals 0 and x equals a 2. Alright, not bad. Okay, so last step, make sure you guys are careful when you realize what trig function you were using. Okay, it's cosine. So this is really cos x equals 0 and cos x equals 2. Alright, so let's use our second function key. Figure this out. What did I do?
You did like cos equals 0, cos equals 0.
Oh, cos equals 2. Sorry. So you got 90. Sorry, 2. Okay, so in here we got x equals 90. Now just be really careful, kind of like that last one we did. When you guys are dealing with like ones, negative ones, or zeros, give yourself a quick little quadrant check, right? Make sure there's no other spot where the cosine is going to be 0. Right, here you got 1, 0, 0, 1, or negative 1. Is there anywhere else besides 90 that the cosine is going to be 0? Cosine. 270. Good job. Yeah. Cosine is going to be 0 at 90 and at 270. But look at your. Right. We can't take 270 here because we only want between 0 and 180. Just one. Just the 90. Just 90.
Oh.
That's the one where your cosine.
I never would have thought that.
What?
If you hadn't mentioned it, I never would have even brought in 270.
I know, right? Because you would have just relied on your calculator, but I'm like calling it a day, right? Yeah. So just whenever it's like zeros or negatives, ones or ones, you want to do this. You just won't be able to check otherwise.
So it's not always going to be like easy like that though, like zeros and ones. Like it can be things that aren't like 90, 80.
Right. So next two are like that. Okay. So what happens when you guys do second cos of 2 though? Good, it's an error, yeah. Same reason why too, because your cosine curve, if I looked at just graphing cos x, the amplitude would have been 1 here. That means your graph will only go to 1 or negative 1, it's not going to go beyond. So we get an error for that. Alright, so our only answer we're going to take would be 93. Now Carly asked a good question. Are they all going to be this easy? What do you guys think? Alright. But, those are, these are right on for agency exams. Those are 2 examples of, things that have come up. Right. These are a little bit tougher. Okay. They take a little while, so you guys don't have a lot of homework tonight to do this a long time. Now notice this one. Find the nearest degree. So right away, make sure we're rounding the correct spot. Whole numbers. Alright, we got 0 to 360. We want to include both. Alright, and let's look at our equation. We've got a lot of stuff going on. So if you want to rewrite it, you can make all those signs into x's.
Oh yeah, we're doing this one.
Yeah, you can do it. Alright, so how do you guys want to solve this? What do we have to do? Move it over. Yeah, we want to get it to 0 first. Okay, that should be your goal. Anytime you see an x squared, you need to make sure it's equal to 0. Okay. Now this is where it gets a little bit complicated. How are we going to factor this? Can we just do a nice double bubble? You could if you wanted to guess and check. If you're a guess and check person.
I can't do that. It doesn't work for me.
Alright, so if you don't want to guess and check, that's fine. What other method did we learn how to factor? Grouping or quadratic formula. All of those methods will work here. Your goal is just to find x. What would most of you guys choose? Grouping, okay. So grouping method is when we multiply the outside. So 3 times negative 2 was a negative, good. Right, so you need things that multiply to negative 6, but can make a positive 5. Well, they need to multiply to negative 6. Alright, so if you did 6 and a negative 1, let's see. Well, that multiplies to give you a negative 6. Well, would this add to be a positive 5? Alright, good. So When you need to group, what we did, we took those two and we replaced them into that middle term, right? So what it becomes is 3x squared plus 6x minus 1x minus 2 equals 0.
Oh, and you have GCF.
Right, and then you split it down the middle. Those of you guys who can do guess and check well, it's way faster than this, but, you know, at least this will be right. So now we want to take the GCF of both parts. So what's your GCF here? 3x, good. All right, make your bubble. We should have an x plus 2. All right. Watch out with the second part. Make sure you take the sign out too. So we have a negative. What's the only thing you can take out of here? 1, isn't it? Right, make your one bubble. Now, when you divide a negative divided by a negative, it's a positive. Same thing over here. Right, your bubbles want to be the same. Right, really important that you get your bubbles the same. Once you have everything factored out, we're going to join the two GCFs together. So 3x minus 1, and then we have an x plus 2. All right. Last step is to take both of these and set them equal to 0. 3x minus 1 equals 0, plus 2 equals 0. This is going to give you guys x equals a negative 2. And when we add 1, divided by 3, it should be a 1/3. How is the factoring? Do you guys remember grouping method at least? Yeah. Okay. So again, it's just another place that makes it tricky. Let's see, what were we originally dealing with? Sine. So this is sine x equals 1/3, and sine x equals a negative 2. What do you guys think is going to happen with that negative 2? Yeah, it's going to be rejected. Nice, Jameson. Yeah, if you want to try it, you get an error there. This one's not going to work. But this one, let's see what's going to happen. All right, we need to figure out our missing degrees. Let's do second sine 1/3. Where did we want to round to? Okay, good. So this would be 19 degrees. Okay. So we have x is 19 degrees. Now we don't want to stop there. We need to think about some other things. Is sine positive or negative? Positive. Good. So we need some quadrant checks. We got the A and the S where sine's positive. 19 degrees is already in my A quadrant. That's looking good. How do we get into the S though?
Minus 19.
Good. Okay. We take our 180 and we minus 19 because we're going to think you're going backward. What'd you get, Andrew? 161. Awesome. Right, so let's see if both of those fit in my interval. They do? Yeah, so we're going what? 0 to 180? Or 0 to 360. Good. Good job. So those are going to be your two answers. All right, why don't you guys see for the next one if I'll start it with you. I want to see if you guys can factor it and at least get to that part. Oh, this is really bad. Hang on, I gotta do this one with you. This is good. I'll give you guys a good variety.
So wait.
Alright. Okay. So let's see. First step, you have all tangents. What should you make them probably? X's. Alright, so let's, rewrite all this stuff.
You can have you should have a negative x squared.
Good, Carly. I like what you were just saying. She said that I shouldn't have a negative x squared, right? You guys don't want that when you try to go to factors. So keep the x squared positive. So you would have to move over the 5x. And do you like the way this looks?
No.
No. So put it into standard form, right? Standard form is when you guys have it like x squared, the x, then the number, the constant.
You can just push around now.
You just have to make sure that your signs stay in front. So you have a positive x squared and then a negative 5x. And what's your 3? Positive or negative? Good, positive. So that's what it has to look like. Oh man, I don't know. Let's see. So we have a 1 in front. Usually those are nice. But do we have factors of 3 that can make a 5? Oh gosh, Frida, what do we have to use? Stupid quadratic formula. Right, this would be a great 6-point question. This would be one if you're going to get a 6-pointer like this. It's right here, because they're combining quadratic formulas, right? Lots of nuts stuff in it. Yeah, Katie?
Would you also use the various
Yeah, you can just complete the square if you want to. The only thing with completing the square is going to be a little tricky is you're going to be dealing with a lot of fractions.
Yeah.
It's true. Yeah, so yeah, I would probably use quadratic or like at least less place making mistakes. So yeah, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. All right. So what's the a here? 1. What's the b? Negative 5 for the c is 3. So just be careful when you guys are entering all this stuff in. I heard somebody say it already, that b is negative, right? And this is negative, so it becomes a positive 5, plus or minus. Okay, underneath my radical. Make sure you guys put this part in at one time here. Just no radical sign. And then 2 times 1 is just 2. All right. So that negative 5 squared. Negative 5 squared minus 4 times 1 times 4. Did you get 13?
Yeah.
Yeah. Oh, God. This is a beast. Alright, so x equals 5 plus or minus radical 13 all over 2. Sorry, say it one more time. Well, technically, this is already solved for, like, it's already, like, solved for, like, what you're, well, we're not dealing with x's. We're dealing with tan x. So this is really tan x.
So would that be like the sign in the bottom?
No. It's like this whole thing is like what tan x is. So think about when you guys don't overthink the problem, okay? I know this part is a little weird. When you guys were dealing with finding your degree, right? You just had one thing to put in. You had to do second tan, just put one thing in. Now, Frida, I think she might have been getting on the right track here. How can we simplify this and make it a little bit nicer? Okay, so if you guys wanted to make this at least a number to deal with, all we have to do is take both roots. So we want to do 5 plus radical 13 over 2, figure out what this is. And then we also want to do 5 minus radical 13 over 2 and figure out what that is. That way, we can kind of make it a little bit nicer to type in. You just want to take care of it. This is not your final answer, so let's keep like, how about we keep 4 decimal places out?
Do you have to do like double parentheses or no?
I would do the top, like, you either need to do the top part first, and then hit like enter, and then divide by the bottom, or do a double parenthesis around the top.
I'll do this.
Me too. Right, so I got 4.3028.
Yeah. But then the second one do that.
Okay. 4.3023. Okay.
And then I got like points like 972, but I don't know if that's okay.
Did you guys get points?
All freshmen, your t-shirt orders and money are due to Mrs. Nag by tomorrow.
Everybody else got this 1.692? Okay, but here's the reason why we want to do it this way, okay? Is you guys are able to look to see possible values here. Is tangent with this one positive or negative? Positive, okay. What about this one? It's a still positive, right? Okay, so this just makes it easier for you guys when you are typing it into the calculator to do. So if we wanted to figure out what x is, let's do, second tan. Second tan.
4.303.
Yep. 4.032.
No, 30.
Oh, sorry, thank you. That would have messed me up. 30.
How many places are you going?
All right. So this is what your degree value is. So what do they ask you to round to? Nearest degree. Okay. So nearest degree? 77. Good. Okay. Awesome. So we have 77 degrees here. And we also have to check the quadrant. They want a tangent being positive. So AS, we should be in the A and the T quadrant here. Right, we already got 77. How do we get into the T quadrant? Add a 20. You got to make sure that you're careful with your direction. So one look forward. So we're going to take 77 plus 180. Where'd you guys get that? 257. So 257. Yeah. So that's just this one part. You remember how yesterday you guys were asking me, like, do you always just get 2 answers?
So now we're gonna get
We might get 4 answers or 3 answers. We could get 1 answer like we had earlier today.
35.
Alright, so let's try this one. So second and 6972.
You get 35? Yeah.
Alright. So 35 degrees.
And then you get,
Again, tangent positives need to be the A and the T. Right, so 35 degrees is here. If you guys want to get into the T, what did you have to do with the 180? Plus it, good. So 215, awesome. So 215 is going to be my other option. So yeah, this time we have 4 options. That would work here. Okay. So you kind of saw a big range of stuff. Some of them are not terrible. Some of them are very long and brutal. So just remember, if you guys can't factor, you have to use quadratic formula, which makes it just very long.
There's like 1,000 pieces in class.
I know. This is the worst test when I have to grade it because, like, there's so many spots where you guys feel like you messed up, and they're all like big point questions. So, here's your homework. It's only 3 questions. Okay, obviously this stuff takes like a little while to do.
What was
Is
the
there any
last
hard ones?
6-point question?
I actually gave you. You guys remember it actually easy to solve. It's way easier than this stuff. I don't know what it was. It was maybe a snow day or something, or we had like a 2-hour delay. Where you guys had to do the area and make your own like rectangle, and like no one had the area of a square formula, a rectangle formula.
I think they'll all know that.
Lane pencil.
Oh, yeah, now I know that. What line pencil is that?
That's volume.